Hello and welcome, my Pixel Pioneers. Today, we'll be covering coding essentials, loop, and keyboard controls. Welcome back. Today, we'll learn how to understand what loops are, repeat actions automatically, control a sprite using the arrow keys, write shorter and more efficient code, and begin planning our final game or animation. Learning goal. Students will understand how loops reduce repetitive coding and how keyboard controls make games more interactive. Looking back, this week we've learned motion, sequencing, debugging, backgrounds, sprites, costumes, and sound effects. Today, we're adding one of the most important programming tools, loops. Part 1, Loops. What is a loop? A loop is a block that repeats its instructions automatically. Instead of writing the same code many times, Scratch repeats it for you. Loops make your code shorter, cleaner, and easier to understand. Loops in everyday life. Loops happen all around us. Examples like walking, heartbeats, riding a bike, ocean waves, a clock ticking, rain falling. Programmers use loops to sit in the same way to repeat actions. Why use loops? Without loops, you'd have move 10 steps, move 10 steps, move 10 steps, move 10 steps, and move 10 steps. Even when you sing it out loud, it sounds so repetitive. So that's why programmers don't write code like this. Instead, they'll put their code in a repeat block. For example, instead of it moving 10 steps 5 times, they'll put in one repeat 5 block with one move 10 steps button. Same result, but way less code. What is a loop? Scratch has three common types of loops. Repeats, which repeats it only a certain number of times. Forever, repeats until the project stops. Or repeat until, which repeats until something happens. Each one has a different purpose and different use. Now, practice activity 1. Try this. Build your own code, and then put one green flag clicked, repeat 10 times, move 15 steps, wait 0.2 seconds. Now I want you to answer, how far did your sprite travel? And what happens if you change the repeat 10 to repeat 20? Now, after you've done this activity, we'll go to the next slide. Animating with loops. Loops can make your sprite look alive. For example, forever, that next costume, wait 0.2 seconds. Now your sprite can do a dance, walk, flap its wings. That's how you get simple code like this walking sprite of Mario. Now, let me demo this code in Scratch. Now, let's return to our Sonic projects from the last day. See, yesterday we already implemented a simple form of loops, which is the forever loop. Now, let's try using loops to make Sonic have some animations. See. To begin, we're going to want it where every time Sonic clicks like a certain arrow, like for example, left or right, or maybe you want to use WSD, so maybe A or D. To simplify things, we'll just use the arrow keys. Now we're gonna take the one right arrow key pressed. Then we're gonna take a repeat until button. Then we're gonna go to operators, which we covered in day 1, and then take the not blank operator block. Then we'll slide in the not blank operator block into the repeat until empty space. Now let's head back to sensing, which we also covered in day 1. And then let's find key, space, key pressed. Now we're gonna put in the gap from before and replace space key with right arrow. Next, we're gonna head into our character's animations. And then let's locate the sprites for when they're moving. It's a little boring for Sonic to only be walking. So how about we just get some full speed running? So 1, 2, 3, 4. Once you find all the sprites for Sonic running, I want everyone to go back to their code. Then we're gonna head to looks. Then we're gonna do switch costume. And then we're gonna locate our running sprites. Then let's just try doing something basic by just making it all back to back. Duplicate again. Now we got 3 and 4. Oops, 4. Now we can duplicate it again. Duplicating blocks helps speed up our time on coding things that we're gonna just use again the same way. Now we change these. Let's test to see how our code looks. Uh-oh. Seems like we're switching costumes too quickly. Let's try stopping the script and maybe adding some move blocks like we did like we saw in the slides. But something you might notice is that it seems like Sonic's moving a bit too slow while running. If you ever encounter this issue, all you need to do is just simply change the time to a smaller number. So let's try changing it to 0.02. So we're gonna copy this, paste, and then paste. So we're gonna just retype it in all of our weight blocks. Try seeing if it looks better now. Perfect. Now, all we have to do is duplicate this code, and we have it so that now, whenever you're doing left or right, you'll always do this. And then maybe something you might notice is that he just stops midway through running. That doesn't really look good. So maybe let's try finding a spray that we can have him stop on, and then he can go to his idle animation. Perfect. We'll use this. So we're taking the switch block. Find the costume. Duplicate its right code. And then now, perfect. It stops. But maybe we can just change it a little bit so that it immediately goes back to our idle animation. What if at the end of our script, put a really short weight block, be like this, it's like 0.01, and then set it to any costume, and then set it to, what's the first costume? Now we just duplicate this over to our left. Now, a little bit too fast for him. Let's try having 0.02. About 0.5. That's way too slow. That's good. Now, no matter left or right, Sonic will skid to a stop, and then it'll stop in place. Now you can feel free to implement code like this for any time you're animating. You can change it up to make it more optimized. Remember scratches, think on your feet. Like I showed yesterday, loops can be used to add sounds, like how we added music to our simple Sonic project yesterday. But we can also use it to repeat sound effects, like maybe like someone collecting a coin, a rocket engine, ocean waves, birds chirping in the distance. Repeated sounds help adding more life to our project. Part 2. Keyboards. Keyboard controls. Many games let their players control the characters with the keyboard. Splash can do this as well. We can use the up arrow, down arrow, left arrow, and right arrow. Each key can tell the sprite how to move. Using the arrow keys. For example, we can do when right arrow key pressed, change X by 10. When left arrow key pressed, change X by -10. When up arrow key pressed, change Y by 10. And when down arrow key pressed, change Y by -10. Now your players can move all around the screen. Practice activity 2. Try making your sprite move to the left, move to the right, move up, and move down. Bonus challenge. Add sound when the sprite moves. Now, I'll give you guys a bit to try to build on your own. And then afterwards, I'll show you how. I'll demo a simple version of something I can make. Depending on your project, it might make sense for your character to be flying around the screen. But for a project like mine, it would make more sense if up arrow made Sonic jump and down arrow just made him crouch. Now, let's try to code that. So, we're gonna duplicate our right arrow script, and let's animate Sonic crouching. Now we're gonna change this from right arrow to down arrow. And then instead of these blocks, and instead instead of having the repeat until, like, we can keep the repeat until, but instead of having run, we're gonna look for his crouch animations. It should be somewhere in the sprite, if your sprite comes with them. Now we're gonna have crouch idle, and then crouch idle 2, and then locate crouch idle 3. Oops, accidentally skipped 1, and then search for crouch idle 1, and then now. You might notice a simple issue. Instead of just crouching once, Sonic infinitely crouches. So instead of having a repeat until block, for the entire animation, we're just gonna put the repeat until block on only one costume, and we'll use crouch 3. Then now look, perfect. Sonic's crouching. We might notice Sonic's still doing the skid animation from before. That doesn't really make any sense now. So how about instead we just duplicate the first part of the code. And then put it in reverse. So we put 3, then 2, then 1, then crouch idle, then now look at that. Sonic instantly crouches and uncrouches perfectly. And he runs with both arrow keys. So now, I would say our game's looking pretty good. But it's kind of weird for Sonic to not move. So now, let's take our code from the slideshow and try adding it here. Now we're gonna get when right arrow key pressed. Then we're gonna have it where, let's have Sonic move. Let's just use the basic one from that. Change X by +10 and -10. Now let's look. So I move forward, it moves backwards. But something weird is that though Sonic's moving in 2 different directions, he runs the same way. To fix that, we're gonna go to our direction, then set our direction, our rotation style to left to right, and then make it where at the start of our movement of our costume script, we're gonna put point in direction +90, and then to the left, we're gonna put -90. Now, Sonic faces right or left, and he stays in that direction even after. Now, our crouch is even in the right way too. Now, all that's left is to code him jumping. Now we're gonna duplicate our movement script and then change it to up arrow. Now we're gonna take a change Y block, then get a repeat 10, and then duplicate it again, and then change this to -10. Now Sonic jumps, and then now all we have to do is only take our costume code, take off this, and then find our jump animations, which if they come with your sprite, they should be somewhere in your sprite, and then try to implement them. For this part, it might be easy to look into the costumes for your sprite. Now, we've located Sonic Jump 1, and then all we have to do is make it where Sonic switches to the costume jump, which should be somewhere here. Let's try to locate jump. That's weird. Oh, oops, we forgot to change it from left arrow to up. Looks a little bit weird. Let's see how that looks. That looks way better. Now, we've just coded a simple way for Sonic to control. Feel free to make Sonic move more smoothly, or make your own character move more smoothly. Now, let's continue with the lesson. Now, let's combine everything. A great Scratch project should combine motion, loops, sounds, costumes, backgrounds, and keyboard controls. These features work together to make games fun to play. Planning your final project. Your final project should include a maze game, a racing game. Could include a maze game, a racing game, a dodge the enemies game, a funny animation, or a space adventure. Think about what you would like to build. Your final project should include motion, sequencing, at least one loop, arrow key movement for games, multiple sprites, backgrounds, costume changes, and sound effects. Today's challenge, try to complete any of these. All of these. Use a repeat loop, use a forever loop. Control your sprite with the arrow keys. Add at least one sound effect. And begin building your final project or animation. Remember, professional programmers don't write more code. They write code smarter. Loops help us create amazing projects with less work. And with that, have fun coding.